All the fish is happy as off through the waves they roll. The fish on the land ain't happy. It's hot cause they in the bowl. But fish in the bowl is lucky. They in for a worse of fate. One day when the boss get hungry, yes, you got me on the plate. What no? Under the sea. Under the sea. Nobody beat us, fry us, and eat us in fricassee.
Our original design was compact with short, high-active chimes that were suspended horizontally within the support structure. After completing the CAD model, we identified possible issues with the design. The major issues were the placement and orientation of the chimes within the compact structure, not allowing for enough room to strike the chimes. A physical model of the original design was not constructed.
Our second design iteration focused on increasing the amount of spacing to strike the chimes. The 4 chimes that were to be struck by the motors were moved to the outside of the support structure and oriented vertically. The 4 chimes to be struck by the solenoids were still hung horizontally in the middle of the structure below the solenoids. A CAD model and a physical structure were created from the second iteration of the design. However, we soon ran into problems with the motors not being able to strike the chimes to produce a quality sound.
To improve the sound quality and resonance of the chimes, we decided to cut them in significantly greater lengths to achieve a lower octave. With this change, we had to completely redesign the support structure and striking mechanisms, which led to our third and final iteration of our chime machine.
Our design features a rectangular structure with 2 smaller 45-degree cut pieces for support. A cross member has been placed midway for holding solenoids and motors. Our 8 chimes are hung from the top of the structure with the use of thread. Below each chime stands its corresponding skewer, which reduces the chime's movement after it has been struck. This prevents them from hitting one another. Our solenoids have been modified with paperclip springs so that a spring return mechanism could be used. Nails were attached to the motor axis to serve as its own striking device. Skewers were also horizontally attached above the 2 motors on each side to stop the nails from overshooting.
The code begins by enabling the pins to output to the solenoids and motors. Pins 2 through 13, with the exception of 9 and 11, corresponded to specific notes. 9 and 11 were still used to reset motor positions. Based on a tempo of 72 beats per minute, the quarter note was calculated to be 790 milliseconds. The duration of the other notes in the song were calculated based off of this value. In all note lengths, there were a series of if and else if statements that determined the actions to be performed, depending on the desired note. If a motor was called, it would cause one of the motors to move in a predetermined direction and then return to a resting position. If a solenoid was activated, the plunger was magnetized for a short time and then released to strike the chime. For all actions, a remaining wait time was calculated from the duration of the note and how much time was taken to perform each action. The time of action was dependent upon the note. After the wait time was performed, the code moved to the next note and repeated the process.